Assalamualaikum. We are from Group 3 and today I would like to give a presentation about our project report, which is overcoming network congestion and latency in mobile networks using 5G. And first of all, I would like to give an introduction to myself, which is my name is MEGAT Mohamad FEDILEH and my mention number is 074713. And it consists of three members, which is Mohamad AMIR, AIZAT bin SAIFULAZAM, and the mention number is 072167. And last but not least is Mohamad WAFI IRFAN bin Mohamad JAILANI, which is the mention number is 073206. Before we go into our slide, I would like to give a quick recap and I would like to show you guys how we do our report. So this is our report for the project. Our report consists of 5 chapters, which is the first one is the introduction to the wireless communication and the evolution to 5G. And then we go through the critical challenges. It's very critical that we have to handle how we are going to do something about the extensive network congestion and also high latency and contemporary mobile networks. And number 3, of course, if there is a challenge, we also need solution. Every challenge, every problem has its own solution. So we come the solution with 5G. Yeah, so 5G is a leverage next generation technologies to mitigate the congestion and latency. And this is our conceptual diagram of the 5G structure. We're going through this one after this. And the fourth one is the conclusion and our future recommendation. And of course, we can't do all this without a reference. So the fifth one is our reference.
Assalamualaikum warahmatullahi wabarakatuh. My name is AIFAN bin Mohamad JAILANI, number meeting 073206. Today I'm going to talk about the challenges for this topic. Okay, for the first one is network congestion. Okay, this happens when too many devices try to use the network at the same time. As a result, the network becomes overloaded and cannot handle traffic properly. This is especially common now with the rise of smartphones, IoT devices, smart home systems, and wearable tech. All the devices are constantly sending and receiving data, putting a huge load on the network because 4G was not designed to support this many high-speed connection. Okay, for the next one is latency. Latency refers to the delay in sending and receiving data. In 4G networks, this delay is usually between 30 to 70 milliseconds. While this might seem fast, it's still too slow for real-time applications like online gaming, virtual reality, and autonomous vehicles, where even small delays can affect performance and safety. Okay, next one is for the context is the number of connected devices is increasing very quickly. By 2030, it's expected that there will be over 30 billion connected devices globally. These include not just phones, but also smart TVs, wearables, vehicles, and more. These trends are largely driven by video streaming, augmented reality, and cloud computing, all of which require a lot of data and a fast, stable connection. These growing demands put a huge strain on existing mobile networks, especially 4G. As a result, users often face slow down speed, dropped calls, video buffering, and poor connections in crowded places like stadium or city centers. To understand more on the pressure on networks, let's look at the number. In 2016, the average smartphone user consumed around 1.97 gigabyte of data per month. In 2024, this jumped to over 20 gigabyte per month, and by 2029, expected to reach more than 42 gigabyte per month. That's a 20-time increase in just over a decade. Okay, why we are choosing 5G is because it is suitable and evolved specifically to tackle these escalating demands and ensure seamless connectivity for the future. Okay, this is the graph for the mobile traffic smartphone worldwide from 2016 to 2019. We can see the increasing usage in mobile data per year. And the last one is 42.38 gigabyte. That's all from me. I'm going to pass to Mugat.
Hello, back with me. So now I would like to give a talk about the conceptual diagram. So this is our conceptual diagram about how we are overcoming network congestion and also latency using 5G. As we can see, this is our conceptual diagram. There's a network slicing, beamforming, small cells, massive MIMO, and also URLLC. All of this is related to how to reduce congestion and also latency. So now, so what can we understand from that conceptual diagram? So it's basically the internet connection of 5G component, everything that I've said just now. And then we have optimized network performance. We can reduce the congestion and also the latency. And the third one is enable future mobile service, which is support real-time and also data-intensive application. 5G, not 4G LTE, we are in the future. Okay, so I'm going through all the things that 5G as a solution can do. First is the network slicing. So basically, we divide a single physical network into multiple virtual network. What is virtual network? It's a VLAN, which is they can actually optimize for specific use cases like high-speed video streaming, or also like me, I like gaming, so I need low latency gaming. Next one is ultra reliable low latency communication, or in short terms is URLLC, is to reduce latency to as low as 1 millisecond. How cool is that? While ensuring near perfect reliability for critical systems. Next one is massive MIMO. What is MIMO actually? MIMO is multiple input, multiple output. So how we can do this, how we can use 5G is basically put dozens or hundreds of antennas at the base station to serve multiple users at once, boosting the capacity and speed. What kind of speed? The network speed. Next, the beamforming, which is we direct focus radio signal to the individual devices rather than broadcasting in all direction. Because in all direction, we know if the network or the radio signal casting to all direction is going to have the traffic, signal, congestion, and latency. And also the beamforming can't do this without small cells, which is lots of small cells deploy compact and low power nodes to enhance coverage and also performance in busy area like Kuala Lumpur or maybe Pulau Pinang. So what's the performance goals for the 5G as a solution? So our performance goal is we want to speed up to 10 gigabytes, latency as low as 1 millisecond, and the ability to connect one also million devices per square kilometer. I think that's all for me. So now we're going to AMIR. Bye.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad AIZAT bin SAIFULAZAM. Number 3072-167. Now I want to continue the presentation, which is the last part of this topic, which is the conclusion and future recommendation. Okay, for the 5G's impact in conclusion, resolve the network congestion and latency with cutting edge technologies. 5G also deliver peak speed exceeding 10 GB per second, 100 times faster than 4G, ultra low latency of 1 millisecond, 10 times better than 4G, and capacity to support billion of connected devices worldwide. So what is the 5G transformative potential? It enables groundbreaking innovation like smart city, autonomous vehicle, and telemedicine. For example, connected traffic system, also real-time navigation. So 5G also lay the foundation for a hyper-connected and data-driven future. So next slide is the future recommendation. For 5G, it need to expand access, partner with governments and telecom providers to bring 5G to rural and undeserved areas, reducing the digital divide, enhance the efficiency, use AI-driven traffic management and energy-efficient hardware to lower the operational cost and environment impact, secure the network, invest in advanced cybersecurity measures such as a real-time threat detection and globally standardized encryption and to protect against growing risks. So my closing thought of this topic, continuous the innovation, investment and collaboration are critical to unlocking 5G's full potential and shaping the next era of connectivity. I think that's all for us from Group 3. Thank you.